1500 तो नहीं हो गया।
Welcome, Gaurav sir.
Hello, sir. Am I audible?
Yes, sir. Audible, sir.
Your voice is echoing, sir.
Yes, sir. So, good evening, all the participants. We have Gaurav Saxena sir with us. So, let me invite Mr. Robin Prakash for introducing and inviting Gaurav Saxena sir for the technical session 6 on introduction and recent avenues in multi-layer perceptron. Robin sir.
Am I audible, Ashish sir?
Yes, sir. Yes, sir. Audible.
Thank you, sir. Good evening, one and all. Our guest for today for the technical session 6 is Mr. Gaurav Saxena, hardware and software developer in embedded systems, Techno Center of Excellence, Jaipur. Mr. Saxena holds a BTech in electronics and communication engineering and an MTech in VLSI design. He is currently pursuing his PhD focused on developing a portable device for detecting contamination in food. With 8 years of teaching experience at Poornima College of Engineering, he has mentored numerous students in electronics and embedded systems. Prior to his academic career, he gained 4 years of industrial experience at Technos Instrument, specializing in embedded system, hardware and software development. His research interests include VLSI design, embedded systems, and food safety technology. Mr. Saxena has published several research papers in reputed journals and actively participates in technical workshops and conferences. He is passionate about bridging the gap between academia and industry through practical applications. His dedication to innovation excellence makes him a valuable contributor to the field of electronics engineering. Sir, we invite you to deliver the session 6 on the topic Introduction and Recent Avenues in Multi-layer Perceptron. With this note, I, Robin Prakash, welcome you, sir. Now, Mike is over to you.
Thank you so much, sir. Thank you so much, sir.
Thank you.
Okay, so today's session is basically based on multi-layer perceptron. So let's start the topic. Right now I am working in Technos Instrument, so I just introduced the company where I am doing work. This is basically the first Raman manufacturing company in India that is work. Raman spectrometer is basically used to categorize the material. So after 94 year of invented Raman spectrometer, India's first Raman spectrometer is manufactured in Jaipur in Techno's instrument in 2008. And we are selling the Raman spectrometer all over the world. Right now we have a several type of Raman spectrometer through which you can categorize the material. Even you can find out the category of the diamond which you are using in your pendle, in your ring. It is fake diamond or it is a real diamond. So there are so many customer for a company. That is the small introduction of my company. Now today we are going to deliver about the topic that is multi-layer perceptron. So I am going to share my screen. Is visible?
Yes, sir. Visible, sir.
Okay. So multi-layer perceptron and the fundamental and advancement. So basically we have to know about what is perceptron, and then we start with single layer perceptron, and then we will move to multi-layer perceptron. So basically perceptron is basically a type of neuron, that is artificial neural network. It is basically identified in 1950, and first artificial neural network is developed by a scientist Frank. Okay, so we will discuss later about this. So what is perceptron? So perceptron is basically a type of artificial neural network through which you can get some input from your sensors, from your receptors, and then with the help of some functions, we can find out then what you are saying, in front of you, or what the object is in front of you. I am giving a small example for that. If suppose a water bottle is placed in front of you, okay, and a person who are sitting in front of the water bottle doesn't know even a single information about water bottle, and he and she was not know before that the bottle is there. He doesn't have any previous knowledge of water bottle. That is the prime first object which is seen, that is a water bottle. So how can a person identify that it is a water bottle? So with the help of eyes, that is basically we can say it is a sensor through which you can see a bottle. Okay, but person doesn't have any information about the bottle, right? Okay. Now what they can get the information from the bottle? First, its color, its size, capacity, diameter, length. Okay, so these all basic information he and she will catch when they say when they see the bottle or water bottle. Okay, but they doesn't have any information about that it is a water bottle. So with the help of these all information is going in our mind. Okay, and in mind there are billions of the neurons who are working on that input which you are seeing from your eyes, and try to identify what is this object. Okay, if we know that this is a water bottle, and when you see a object look like a water bottle, then you easily identify it is a water bottle because you have the previous knowledge about the water bottle. So we have some inputs, we have some calculation in our mind, and then we can judge that it is a particular object. So this whole term is basically a neural network in a human being, and because of this everybody can identify any object. But if they have previous information, then we can say that it is a water bottle, it is a bag, it is a wall, everything. But if you don't know previously, if you don't have any information, then this is a new object for you. So how can you relate it? You just take the inputs from your sensory organs. You can touch them, you can feel them, you can see the object, diameter, length, weight, capacity, whatever, color, and then you can collect all this information to your brain, and millions and billions of the neurons work on that all inputs and try to identify or relate to identify that it is the basic object, like this. This is the basically whole neural network, and scientists are trying to make a same neural network in artificial form. That is known as artificial neural network. It means they are trying to make a machine who can do the work as same as the human being. So the neural network is basically converted into artificial neural network. Neural network is a term which is used for human being, but artificial neural network is the term which is used for a machine. But the working of both the system are same. Both the objects are trying to identify what is the object. Okay, so this is basically the small example through which we can get the information about neural network and artificial neural network, because the word perceptron is very important. That's why I am explaining all of this. Okay, let's move ahead. The AI ecosystem. Now there are several terms which are basically confusing for most of the person, like AI, ML, NN, neural network, artificial neural network, deep learning, convolution neural network. So these all terms are very confusing. So they are related to each other. So if we know about the hierarchy of all these terms, we can identify on which field you are working on it. For an example, if suppose I am talking about all these terminologies, let's say there is a circle, and this circle is AI, artificial intelligence. Okay, we can say it is a set AI. Now in which there is another circle. Okay, and this another circle is basically what? Machine learning, ML. If we can say that ML is a subset of AI, and in which there is another circle. Okay, and in which what is that is neural network, NN. That is again the subset of machine learning. Then there is another subset, and what is it called? Artificial neural network, ANN. ANN is a subset of NN. NN is a subset of ML. ML is a subset of AI. And in the same way, there is another subset of deep learning. Deep learning is the subset of ANN. So this is basically the structure, and all these terms are related to each other. Some are sets, some are subset, but they are interconnected. Okay, so this is basically the hierarchy which we have to know. Now move further. So this hierarchy is already I explained. Now introduction to artificial intelligence. That is the very big we can say set. All the terminologies which I already explained, that is subset of AI. So AI is basically create some intelligent agents that reason, learn, and act autonomously. It will work autonomously when they learn from something. Learn from something from where? From the receptors. From the you can relate all these terms with the human being. If suppose a machine can identify any object, definitely it will work like the same as the human can identify that particular object. Both the working are same. So you can relate every term in artificial intelligence with the human being, or neural network with the artificial neural network. Artificial neural network basically mimic of neural network, is nothing. Okay, capabilities of AI: it enable computers to perform tasks requiring human intelligence. You can see that human intelligence, the machine is working like a human. Okay, application: there are several applications which can perform by artificial intelligence, like image recognition, natural language processing, and decision making. Sometimes it will be very important for say that decision making. If I will give you the example of decision making using single layer perceptron in the further slides, and then we will move to multi-layer perceptron. Okay, There are several types of, three types we can say that artificial intelligence. First is narrow AI, second is general AI, and third is super AI. Okay, so narrow AI is basically used for a specific task like Excel. If we want to make some formulas in Excel or create some formula in Excel, then narrow AI is used. Or in case of you are playing a chess or for image recognition, you are working in narrow AI domain. In general AI, we can see that it is basically replication of human intelligence in most of the domains. Right now, it is most of the domains, it is replication. The same thinking processing which a human being has, the machine are doing the same. Okay, that is basically a general AI part. Super AI is basically hypothetical concept of machine, and it is surpassing human intelligence. So these are the three types of artificial intelligence. Okay. Now, fundamental of neural network, as I already told you about the neural network, but these two important things are brain inspired design and AI building block. So, NN mimic the human brain, as I already told you, is structure and functionality using interconnected neurons to process information. To process information means when you are getting something, your brain start to work on them and get a fixed decision that what the output of this. For an example, if suppose a hot object is put in your hand, we can say on the right hand. Suppose a hot object is put on your right hand. Okay, now what is going on in your body? The information, the sensory organ like skin is a sensor. Okay, the sensory organ gives the signal to your mind. So the sensory organ skin is basically your input, and multiple neurons in the mind start to work what reaction you will going to do. You definitely put your hand away from that hot object, but right hand, not left hand. It means which hand you have to put away from that hot object, it will be decided by your brain. Okay, it doesn't like if a hot object on the right hand, but you leave left hand. It is not going on. You always put your hand or remove your hand from the hot object where the mind is start where the mind gives the signal to the body that the right hand is facing that problem. Remove that hand. Okay, so these are basically a neural network. Okay, same is AI, or we can say ANN. Neural network are fundamentals to various AI application, including image recognition, natural language processing, as we discussed in the previous slide. Okay, now learning from data in neural network. How can you learn data from the neural network? When you having a several inputs, we can say that that is data input. Okay, so if you are getting more input, then definitely you have more knowledgeable. If you are getting more information about politics, then definitely you will speak up more about the politics. So data input in large data set are fed into the neural network. A neural network means in a human brain, we can say in a human brain. If suppose a person who is start to reading newspaper daily, and after 20 years definitely he has a very political sports knowledge because he is reading continuously newspaper since 20 years back. Okay, so they have we can say he and she have very a large amount of data in their neural, in their mind. Okay, so for getting something better, you have to get a better or large data set, but specific, or we can say appropriate. It is not anomalous. Second is weight adjustment. I will explain weight adjustment. What is weight adjustment? Data input is good. You are getting something from newspaper or something book or sports or whatever the inputs, whatever the data set. That is depends upon your interest or whatever the work you are doing. Okay, but what is weight adjustment? Basically, I am giving the example. On your right hand, a hot object is placed. Okay, and your mind is decided and leave the right hand, not left hand. I already told you. So this neurons decided on the behalf of weight. Okay, which hand has to be removed from that object. It can be decided with the help of weights adjustment. For an example, if suppose a very not so hot object is placed on your skin, and it will be not so much paining for you, so you cannot leave your hand, but you know that there is a something hot on my right hand. So neurons decided that it is we can say affordable. It is basically not giving some not giving a very large pain, so we don't have to remove my hand from that object. That will decided by your neuron with the help of weight. But if suppose you put your hand into the fire, then immediately weight decided that you have to remove your hand. Your neurons getting activated with the help of these weight. So weight adjustment means how much is how much the things are harm for you, or we can say if it is in the limited amount then it's okay, and if it is in the large amount then remove your hand or remove something else. So this is the weight adjustment in the perceptron or in the neural network. Third is pattern recognition. Pattern recognition means the data input, what the data is coming in the neural network, then weight adjustment, then the network identify what type of the pattern is making in your data set. It can be identified. And because of this pattern recognition, it will start to predict. That is the fourth step of the neural network, right? That is the prediction. The trained network can make prediction on new data. The new data is coming, then you can know that this is what, because you have the previous pattern recognition parameter. That's why. So this is basically a neural network learning from the data. Artificial neural network. Obviously, it is the subset of AI. It has three layer: input layer, hidden layer, and output layer. Okay, input layer, I already told you what is input layer. The data which you are getting from any sensor. If you are a human being, then definitely there is a neural network, not artificial, and you are getting the signal from your biological sensors. But in case of artificial neural network, we have some manufactured sensor like temperature sensor, pressure sensor, barometer, magnetometer. There are so many sensors available. That will depend upon you in which field you are doing work. So input layer is what input parameters are coming. Okay, I will give you the example with the help of a diagram. Okay, let's see. We have a data, very small data, only just to understand what is input layer or hidden layer or output. So let's say we have a data set of let's say two things. One is IQ level of a student, and how much are he is doing study. And with the help of these two parameters, we can identify that it will be pass in the exam or it may be fail. Okay, that will be the output. So IQ is basically input. So let's say input parameter, we can say x1, and how much are he and she is doing study. Let's say it is another parameter, input parameter, that is x2. Okay, and because of these two parameter, we can judge it will be pass or fail. Let's say a student has a IQ level of 95. Okay, and he is doing study for 3 hours per day, or let's say per day. Okay, and another student has the IQ level of 115, and he is doing study 4 hours. Okay, and on behalf of this, we can say that the first student is maybe fail and the second student maybe pass. Let us assume. Okay, so because of these data set, how can artificial neural network start to work? Okay, so first of all, I already told you in artificial neural network, first a layer is input layer. As you can see in your screen, input layer. So what is the input layer in that particular data set? There are two inputs, x1 and x2. So we can say there are two inputs. So we can make two circles. Okay. First is x1 and second is x2. Okay. x2. Okay. This is basically input layer. This is what? This is input layer. Okay. Because x1 and x2 are input. And these input layers are coming in our brain. It means a hidden layer. This is a hidden layer, and this hidden layer is work like it can not be seen by us. Basically, it is working in our mind, that is neurons, who can processing, who can taking decision, that is hidden layer. And all these input are coming to the hidden layer. And I already explained what is weight. So we have assigning some weight, let's say W1 and W2. And another parameter which we add is bias, that is BI. What is bias? I will explain it to you. Okay. Now hidden layer has two steps. It performs two steps to predict the output. Maybe it is fail or pass. That is the output. So how can it be decided that it will be the student will be pass or fail? It will work in two steps. That is step number 1, and that is step number 2. Okay. Now in step number 1, what going on? In step number 1, it is basically to sum the values only. So if we are talking about step number 1, so step 1 in the hidden layer, what's working it? It's working to multiply your input with the weights and add them, or we can say summation of all the parameters. So let's say another variable, that is z, is equals to W1 is multiplied by x1 plus W2 is multiplied by x2. Okay. So the input x1, x2 is multiplied with the respective weights, and when we add into them, that is the step number 1, which is performed by the hidden layer, which is basically performed by the neuron in our mind. And we can also add a variable, a small thing, that is BI. Basically, what is BI? For an example, if suppose W1 and W2 will be 0, maybe. If W1 and W2 may be 0, so Z is equals to 0 if BI is not present there. So BI is a very small value, which is not be a 0. So Z is not equals to 0. That's why we add a small value BI. Okay. So this is the first step which is performed by the hidden layer. Now the second step is basically what? Second step is activation function. This second step is basically activation function. Okay. Now activation function is start to identify on the behalf of the binary logic that it may be fail or pass, because we are working in a binary form. Binary means is yes or no, true or false, 0 or 1, that is binary. Okay. So if a student is failed, then it will be 0. If a student pass, we get 1 at the output. So we are working on a binary decision making system in artificial neural network, in which first step is we already done. Now the second step is we have to activate the activation function, who can find out the exactly what output is coming. Okay, so there are so many activation function in the artificial neural network. One is basically activation function is step function. So in step number 2, one activation function we can say is it step function. Okay, and we can say second is sigmoid, and there are so many so many functions are there. So sigmoid function. So these functions are basically used to get the final output on the behalf of the input in the step number 1. So step function is same as you already studied in signal and system. Like if we are talking about the step function, then it is working like this, because we are working on binary. So what going on in that, it is axis, like this is z axis, this is 0, okay, and let's say it is a function of fz. Okay, now step function is 0 when value is less than 0, and it's 1 when value is greater than or equals to 0. So this is basically a step function. You can write into the equation form also. If the value of z, what is z? Z is basically the step number 1 parameter where we added the multiplication of input with the weights along with the bias. So z is basically w1 x1 plus w2 x2 plus bi, only for this particular example. Okay, so if value of z is less than 0, it means in the step function, if z is less than 0, your value is 0, and if your value of z is greater than 0 or equals to 0, you're getting 1. So this is 0 and this is 1. So this is the basic example of a step function in activation function. So second step is performed by the hidden layer is activation function, and there are so many activation function in which we are discuss about step function. It will be work on 0 and 1. In the same way, you can work with the sigmoid function also. It is another artificial neural network activation function in which you can see that I will make the graph of that also. Let's say there is axis and it's going like this. Okay, now what is this? I am telling you, this is 0 as we all know. This is z. This intersection point is basically 0.5. It means half, just half probability we can say that. Below this, the value is 0. It means 0.5. Below 0.5, value is 0. And above 0.5, we get 1. So this is basically a sigmoid function. So this function is also work for us because it is working on the again binary format. If the value of z is less than 0, if the value of z is less than 0.5, then ultimately output is 0. Output 0 means student fail. And if we are getting the value of z greater than 0.5, then definitely we getting 1. It means that student will be passed. So that will be the decision taken by the activation function on the behalf of step 1. That is the addition of all inputs with the multiplication with the weights and bias and all of this. So this is basically a simple single layer perceptron of artificial neural network. So this is a small example which I am giving to you, and there are so many perceptron model. One is the single layer perceptron model, which I am already discussed in this slide with the small example of data set of IQ and study R. And second is multi-layer perceptron model is also which we are going to be discussed. So I think it will be clear to you. Now come back to the presentation. So activation function can get the final output according to this activation function, which will get the information about Z. Okay. So these all layers we already discussed. That's input layer. We already discussed hidden layers, output layers. Okay. Now differentiating NN, ANN, and deep learning. We already see that there is a very interactive graph between all these terminologies. Like one is the subset of the previous one. We can say that ANN is the subset of AI. Deep learning is the subset of ML. All terminologies we already discussed, and they are interconnected to each other, as you can see in the figure also. So general term for brain inspired network is neural network. Specific implementation of NN with interconnected nodes are artificial neural network. And if you are talking about deep learning, subfield using ANN with multiple hidden layers. Multiple hidden layers means there are so many hidden layers and so many activation functions who are working with simultaneously. That is deep learning. The role of deep learning in AI and ML. We are not going to discuss so much more in deep learning, but there is a small, explanation of deep learning. Increase complexity. If you are very complex, data set, if your system is very complex, or you're working on a very complex software. For an example, if I am going to the example of a Raman spectrometer, which is manufactured in my company, the IT software is working in deep learning because the software they have made using deep learning to identify the material characterization, or how much molecules of which chemicals are mixed in that particular mixture. All things are identified only because of deep learning. It is not only because it cannot be done by AI, not because of ANN, because of only deep learning, because a very high precision is required. So it is a very complex term. A very high precision is required to identify a particular molecule in femtometer. So it is very complex. So in that case, you have to work in a deep learning model. Enhance accuracy. If you want to increase the accuracy, you have to work in deep learning. Automation, feature extraction. Then deep learning model extract features, relevant features according to the data automatically. Application, there are so many applications you can use in healthcare, in finance, in transportation, and in manufacturing also. That will be depend upon the complexity of the system. But there are some challenges and limitations. Data requirement is very challenging. A proper data requirement, we can say that. DL models need vast amount of high quality data for training. High quality, it means your data set is be perfect. It means your input has to be perfect. Black box problem. Inner working of DL model can be difficult to interpret it. Definitely, there is a very complex problem. That's why. Computational power. Training and running DL model requires significant computational resources. Computational power is very high in deep learning. And we have to make it because we have a very large amount of data set with high quality. That's why computational power is high. So the future advancement in AI and ML, hybrid model, edge computing, explaining AI. So all of these are basically advancement future. Single layer perceptron. So I already explained this term. So there is no need of this slide to explain what is single layer perceptron. I already told with this example. This is basically a single layer perceptron. How it is single layer? Because only a single hidden layer is there. That's why it is a single layer perceptron. If there are multiple neurons or multiple hidden layers are there, so it is multi-layer perceptron. So I already explained what is perceptron. It is a very simplest type of artificial neural network, and it will be inspired by biological neurons. Okay, definitely there are some weights and bias are required, which we already discussed. Foundation of machine learning. Perceptron forms the basis for more complex neural network architecture, essential for understanding deep learning model also. This is basically the biological inspiration and history. Biological, basically the ANN model is developed definitely with the help of neural network. Human neural network, we can say. Human have a neural network through which they can doing all of the work in the same way. Why machine will not do the same work? So we are developed ANN. So biological neuron perceptron stem from brain neuron that receive, process, and generate signal. Perceptron stem from brain. Okay, neurons that receive, process, and generate signal. Generate signal means it is output. Receive it means it input, and process it basically hidden layer. So all these three terms in the biological terminology are similar like in artificial intelligence: input layer, hidden layer, and output layer. Frank, I already told you in 1950, first artificial perceptron is developed by Frank in 1950. Early AI research, perceptron faced limitation leading to a decline in research in 1960 to 70. That's why AI is very lack. Otherwise, it is a very huge field. structure and component of a single layer perceptron. Input, wait, bias, and activation function. All of 4 terminologies I already covered, so not take so much time on this. Activation function and decision boundary. I already give you an example of a step function, a sigmoid function, that is the activation function, which is used to get the output on behalf of the input, right? Okay, now decision boundary. Decision boundary is the last, we can say, activation function last task to perform them. It is yes or no, and if it is no, then there is an error. And how can you remove it? Definitely you increase your input level, you start with the work on the sigmoid function, your activation function, and then your decision boundaries will be start to work very well. So sigmoid function classify data into 2 classes. Sigmoid function, that is basically used for binary activation. That is the training of a single layer perceptron: input data, output comparison, error calculation, and then adjust the weight. So when you is starting to adjust the weight, automatically, definitely you getting the better result. So weight adjustment is basically in the artificial neural network. Weight adjustment is automatic process through which you can get minimum error. So when you're getting minimum error, your weight will be fixed. Learning rule and weight updates. Perceptron learning rule. Simple yet effective algorithm for update weight. Simple yet effective algorithm for updating weight. Literally, we adjust weight proportional to the error between actual and target output. So basically, perceptron learning rule is depend upon the weight adjustment, input, and your activation function. Okay, the weight adjustment is basically weight adjustment is a very important task, and it's aimed to take a particular value through which you can getting the minimum error. Minimum error means your function, activation function, will give you the better result. Your accuracy level will be increased if you adjust the weight. But it is not a manual process. You cannot assign a value, manual number to any layers. Definitely, it is an automatic process. But if your system is not capable to making a such type of weight adjustments through which you can get the minimum error, then definitely you have to improve the or upgrade the system. And what are the requirement to upgrade the system? That is depend upon your system. Capabilities and limitation of single layer perceptron. Single layer of perceptron, basically linear separable data. What is linear separable data? I will explain you what is linear separable data, and where the problem is facing in single layer perceptron. That's why we are jumping into multi-layer perceptron. So in single layer perceptron, what the problem is, I will explain again in the slide. Okay. So what are the problems facing in single layer perceptron, and what is linear separable problem? You can see that there is a word linear separable data, linear separable problem, SLP. So basically what happened if suppose we have a linear separable problem. If suppose we have a linear separable problem, it what does mean? It means like if suppose there is a data points, and they are look like this. One type of data is there and another type of data is there. It means you can easily separate them by initializing a single line like this. You can easily separable. It can be easily separable, and you can identify what is cross and what is zeros, and you can start to predict the system, and your system will start to predict what will be the output. This type of the problem is linear separable problem, and it can be easily performed by By what? By single layer perceptron. Okay, but there is a problem in multi-layer in single layer perceptron when your data is not in that format. If suppose your data is in that format, or your data point is in mixed form, in that case there is a very huge problem with single layer perceptron to not identify or not taking any decision because your data set is totally mixed. So here you can take decision 1 and 0, but in that case you cannot take decision using single layer perceptron. So there is a limitation of single layer perceptron, and to remove this problem we have to use multi layer perceptron, that is MLP. So that is the disadvantage of single layer perceptron, that is the limitation of single layer perceptron. So linear separable data is there, so it will be easily work for you. But if it is not linear separable, then there is a problem and you have to be switched to non-linear separable data. If suppose data is non-linearly separable, then definitely you have to move to multi-layer perceptron. So application, if we are discussing about the application, definitely it is image classification, medical diagnostics, financial prediction. So if we are talking about image classification, basic image classification tasks like color, shape. If you are talking about color, okay, image classification. If you are talking about the color, if you can mix several color and then you can try to identify which type of color are in the mixture of that particular color using single layer perceptron, then there is a very difficult task, or maybe it will not perform by this particular single layer perceptron. If there are two color, three color, four color, but if they are not mixed to each other, then you can easily separable, then single layer perceptron can easily work. In the same case, shape separation, if there are several identical shapes are there, single layer perceptron are very well work on this, but otherwise it will be problematic. Medical diagnostic, simple system, simple things in the medical data you can diagnose easily by single layer perceptron, but if the data will be complex, then you have to be switched to multi-layer perceptron. Financial prediction in the same case. So conclusion and future of single layer perceptron is what? Foundation for advanced network, specific application and future advancement. So SLP, that is single layer perceptron, provide fundamental understanding for complex architecture, but valuable certain tasks and education purpose. These are two limitations. I already told you the limitation with the help of example. These are figure if the data is linear separable, or if data is not linearly separable, then how can you start work with non-linear data. So now to start work with the multi-layer perceptron, because there are some limitation. There is definitely a limitation multi-layer perceptron also. We will discuss in the last of the slide. But single-layer perceptron have very huge problem. If the system is polynomial, or we can say there are degree of freedom is very high, then single-layer perceptron cannot identify your output. So multi-layer perceptron is there. So multi-layer perceptron is a powerful neural network architecture, and its advantage over single-layer perceptron that it's wide-ranging application in machine learning and data science. So now we start understanding multi-layer perceptron. Multi-layer perceptron are artificial neural network with layered structure, input layer, hidden layer. There are three things which are very similar to the single-layer perceptron: input layer, hidden layer, and output layer. These are the same. But the hidden layer, in that case, in multi-layer perceptron, is not a single. It may be multiple. Okay, so in MLP, the artificial neural network with layered structure, the layered structure is input, hidden, and output, and each node, a node in each layer are interconnected by weight connection, as same as the single-layer perceptron. Overview, if we are talking about the overview, MLP excel at solving complex problems like image recognition, natural language processing, and it more effective as compared to the linear separable data. The first is feed-forward neural network structure. Feed-forward neural network structure. Neural network we already discussed. What is feed-forward, and how can these three three layers are there. Input layer, definitely it will be receive data or features. Features like if a object is put in your in front of you, then you identify the color, size, shape, capacity, weight. That will be the basically input layer data, features data, and then it will be processed by hidden layer, and then finally output layer, who can produce, who can predict, who can classify that which type of the object is it. Now, component of MLP is input layer, and in input layer, what is it? The data entry point. The first layer is input layer, and the first point which is very important is data entry point. The starting point for data input into the network, from where the data is coming, that is important. Second is features representation. The data which are coming is useful or not? Is it is giving any feature or not? It is helpful for recognition or not? That is important. So feature representation, each node represent features or attributes of the input data. Then data pre-processing, often involving normalization or scaling of input feature. Data pre-processing means when your data is entering from the entry node, then processing is simultaneously started and try to identify what you want to from the system. That is pre-processing. So these are basically now second is hidden component, hidden layer we can say. Component of MLP, that is hidden layer. So first is input layer, as you can see in the figure. Second is hidden layer. Third is another hidden layer, and then output layer. So non-linear transformation. Non-linear transformation means if the system is non-linear, if your variables are, if your data set is complex, it is not linear separable, your data is mixed, there are so many features, then there is a problem, very complex problem. So hidden layer is try to resolve it and try to identify what we will produce the output. So non-linear transformation where complex computation and feature extraction occurs. Model complexity. Number of hidden layers and nodes determine model complexity. Model complexity means if how many hidden layers are required to particular problem, to particular complex problem, how can you resolve it? How many hidden layers and neurons are required to solve this particular problem? That will be very important, and it may be complex. Information flow. Output of one hidden layer become input for the next. If we are talking about so many hidden layers in the MLP, then definitely if one hidden layer take the decision, and this decision will be the output of that particular hidden layer, but it will be the input of the second hidden layer. Second hidden layer start to predict according to your system, according to your performance, according to your ANN, we can say that, and then start to produce output, and this particular output of that particular hidden layer is the input of the third one. So this process is going on and going on till we are not getting a sufficient or accurate result, we can say that. Component of MLP, final prediction, task specific structure. This is the third layer, that is output layer. So the output may be in the three turn. First is final prediction, produces classification or prediction based on the process information. What process is doing by your hidden layers or your neurons. On the behalf of this, we can get the prediction. Task specific structure. If number of nodes depend on the task, single node for binary classification, as we already seen in the binary classification 0 or 1, single nodes are required, and we are only draw a single node where the two functions are performing. In the first is basically summation of all input with the weight, summation of all the multiplication of input with the weight, and the second is the activation function. So this is basically binary classification. But number of nodes, how many number of nodes are required, that is the task specific structure. Interpretation, output is interpreted based on the problem domain, which type of the problem, how much complex is your problem, that will be interpreted by output layer. Now activation function in MLP. What type of the activation function is required in MLP? As we already seen in the single layer perceptron, about two activation function. First is step and second is sigmoid. Here we are also try to see how many or a very popular activation function. So first is, what is the role of activation function? Introduce non-linearity into the network. If suppose is there a network in non-linear format, enabling MLP to learn complex pattern. They apply non-linear transformation to weight some of the inputs, as we already done in the single layer perceptron. And the type of the activation function which is used in MLP is sigmoid function. We already draw the graph of sigmoid function. ReLU function and 10H function is the two new functions, we can say. ReLU function is effective for training deep networks. Okay, it is very important activation function. And 10S similar to sigmoid because it is moving between -1 to 1, but sigmoid is moving from 0 to 1, and in tangent it is moving between -1 to 1. So it may make the decision from -1 or 1 or between them. So how much value between them is basically the output. Okay, if suppose the value is 0, then it will give you information that it may be pass, maybe fail, because 0 is the mid value of -1 and 1. If your value is going to the positive term, it means greater than 0 but less than 1, then it will be show the result that maybe student 75%, we can say that the system is saying 1, it means pass. And if suppose your system is giving, or yes, your activation function giving the result below the 0, it means in the minus 0.5 or minus 0.8, it means the student will be fail. Okay. Now forward propagation in MLP. What is forward propagation? Definitely the hidden layers are getting the signals and start to work on them and get a final result and put the final result to the next hidden layer. Then your responsibility to find out better result. And again you start to work on the new inputs and then again forward to the next hidden layer to think about that. So forward propagation in MLP has 4 steps. First is input receptor, data enters the input layer, weighted some calculation, some calculation weight are required, activation function application, their output propagation. I think these 4 steps we already discussed, but activation function, sometime we are working on single layer, so it will be binary separable, but we are working in MLP, it is non-linear transformation. So accordingly, weights are very important to identify the output. Now, second is backward propagation in MLP. Backward propagation is basically what? If suppose one hidden layer is not giving the right information to the next one, the next one again back send to the previous one that your information is not wrong according to the other hidden layers. So that is the back propagation, and it will be only because of the error calculation, error propagation, and then it start to adjust the weight and repetitive improvement by iteration process. This iteration is going into again and again to improve their accuracy, to improve or to reduce the error. So you know that the system is the output is like this, but you are not getting the output. So definitely it will give back to the signal to the hidden layers that you are not giving the right input. Please try to adjust your weight and give me the better output. So the system back propagation is in MLP is required. Training and optimization, data processing. Training and optimization is basically very important in MLP, and training of a data set, but pre-processing. So pre-processing, you have to be clean your data, normalizing, and feature engineering is required. Cleaning data means remove or correct inconsistent and noisy data. If suppose your data is not accurate, if some values are there who interfere in your prediction and not getting your appropriate output, you have to be identified in your data set and remove it immediately and make it more pure data set. The more pure data is required for input layer to get the prediction at the output layer. So whatever you giving the input to your system will giving the same output. That's why. Normalization. Scale features to a common range for better conversions. Scaling function, we are always using a scaling function. Scaling function in the mathematics. Normalization is required. So in the pre-processing, normalization function is working. Feature engineering. create new feature or transform existing one for improved performance. Feature engineering means you create new features. You try to create new features. That's why you can getting your result better. Okay, so existing features you can create new features or transform existing ones for improved performance of your system for getting better output with less amount of time. That is pre-processing. Training and optimization, model training. So initialize weight, set initial random weight for the network, then forward pass. And because of this forward pass, we can calculate the error. This error is if this error is high, then we start backward pass, and the iteration is going into a loop till now, when we are not getting the better output. So this is going in the MLP, model training model. Training and optimization, model optimization. Training and optimization means how much your system optimizely trained your data to getting the better result. Okay, so first step to clean your data from anything or normalization and whatever you are doing with the input. And then in the hidden layers, there the activation function are working well or not. Okay, so optimization and training both are important in model optimization. Gradient descent, learning rate tuning, regularization, and early stopping. Application of MLP, we are talking about MLP application, that is image recognition is we can say that example of MLP. Object detection, identify and locate object within image. If for an example, if suppose you trained a system, like if a human being is front of the camera, a square bracket it will be available on that face. So you can also do with the using MLP programming. MLP, we can multi-layer perceptron. So object detection you can do with the MLP. Facial recognition, if suppose you are happy, if you are sad, this facial recognition you can also do with MLP. Image classification is which image is type something else, which shape of image style something else. There are different shape we can make our faces. So image recognition is also, or classification is also the application of MLP. Application of MLP in natural language processing, text classification, sentiment analysis, and machine translation. Categorize text document into predefined classes, determine the emotional tone behind text data, translate text from one language to another. That is the application, natural language processing. We can also see the application of MLP in time series analysis, data input, pattern recognition, forecasting, and application. This data you can already you can see in the stock market type applications, and this can be predicted to which stock will can say down tomorrow or up tomorrow. We can predict on the behalf of the previous 3 4 5 years data, and your system will tell you that tomorrow this particular company share will be down. Okay, so this type of problem can be solved by MLP. Advantage of MLP: universal function approximator, nonlinear relation, and adaptability. Universal function approximator means can approximate any continuous function, give sufficient complexity. Approximate any continuous function. Capable of capturing complex nonlinear pattern in data. If suppose your data is nonlinear, as we already discussed, if your data is nonlinear, if your data is polynomial format, it is not in a single line format, then you can work with MLP. It is the most important advantages over single layer perceptron. Adaptability can be applied to a wide range of problem and data type. Now, there are limitation of MLP, as we are already told you. There are some limitation in single layer, same in the MLP. There are some limitation. Overfitting risk can memorize trained data, leading to poor generalization. Overfitting. Computational expense. Training can be resource intensive for large data set. Black box nature, difficult to interpret decision making process. If suppose we are not getting any neuron, we are not having information about the neuron, then black box nature, difficult to interpret it. There is a problem. So overfitting, computational expense, and black box nature. MLP in unsupervised learning. So there are two types of learning: supervised learning, unsupervised learning. So if we are talking about MLP in unsupervised learning, then autoencoder and clustering. Autoencoder is what? MLP can be used to create autoencoder for dimensionality reduce and feature learning. They compress input data into a lower dimensional representation. If suppose your input data is very high in dimensional, then it will be converted into a low dimensional to represent or to for input of the input layer, for input to input layer. Clustering format. MLP can be adaptable for clustering tasks by learning representation that group similar data points together in the feature space. MLP in reinforcement learning. Start representation, policy learning, value estimation, decision making. These all are the MLP reinforcement learning. You can also do the MLP using this case study, as I already mentioned in the slide, image classification. You can make a data set. Okay, if you don't want to make, you can download from MNIST handwritten data set. 60,000 training images are there. Then MLP architecture of input layer is 784 nodes, 2 hidden layers, and output layer is 10. And finally, you're getting the result of 98% accuracy with 20 epoch of training. Epoch means there are iteration process. Till now, you are not getting maximum accuracy. So after all these of 60,000 training images are there, and so many high architecture of MLP, you are getting 98% of accuracy. This is basically a small case study. Second, MLP in natural language processing, task sentimental analysis. Classify movie review as positive or negative using MLP. You can classify your movies review as positive or negative, and you can put this information to your system and start to learn about them, and then you can find out which type of which type of the movie is positive or negative, or which type of movie is natural language processing or not. Case study MLP in time series forecasting. You can predict the stock market or not. I already told you. You can getting the 5 years data, 10 years data of a particular company, and the data you can first of all clearing them and then put into your system, and your system will start to work on them, apply some function, activation function who can identify the output, and you will predict then tomorrow what will going on in a particular stock market. That will be. And this case study, data preparation, historical stock prices pre-processed and normalized, then 30 days data, then use 5 years model preparation, and then 85% accuracy. Future direction, explanatory in MLP, interpretable model, feature important, visualization techniques. This is the future of MLP. Future direction, resource efficiency, model compression, efficient training, hardware optimization. These all are the future direction of MLP. Hybrid architecture is also. Hybrid architecture means you are mixing 2 or 3 systems. MLP with CNN. CNN is basically convolutional neural network. It is the subset of deep learning. You can see that deep learning is the subset of what? Deep learning is the subset of, I already told you, ANN maybe. So CNN is the subset of deep learning. So when you mix MLP with CNN, then there is a hybrid architecture, and you can improve your complexity. You can improve or resolve the complexity. Same MLP with RNN, recurrent neural network. That is a new term which are coming. Recurrent neural network, convolutional neural network, artificial neural network. Okay, MLP transformer. New transformer structure is a new terminology which is coming in the AI. Merging MLP with transformer architecture for better natural language understanding. Ethical consideration in MLP development, bias mitigation, privacy concern, transparency. when you are going to develop some ethical consideration in MLP. MLP in healthcare, diagnostics support, medical imaging, patient monitoring, genetic analysis. MLP in finance, risk assessment, creating a score, fraud detection. You can do whatever you want in finance. So there are two point, that is credit scoring, and for fraud detection you can put more input parameter, you can getting more result. MLP in robotics, motion planning, environmental perceptron, path planning, execution. In case of robotics, we can use drone also for MLP. MLP in environmental science, climate modeling. You can see that tomorrow there is a rainy season. You can getting the information from news or app because of this MLP. So weather prediction, climate change analysis, ecosystem modeling, all of things can be done by using MLP. MLP in education, personalized learning, student performance prediction, adaptive content delivery, early intervention, all of these things related to your child you can do with MLP. MLP in agriculture, crop management. In crop management, that is a basically application. These are the application. Yield prediction, irrigation optimization, pest detection. The pest is required or not, or when it is required, how much water is required in field or not, is the crop is required, if the water is required for this crop and how much quantity. That will all things we can predict, and we can give a appropriate quantity of that particular object to the field. MLP in energy sector, smart grid management. Energy sector, if we are talking about energy sector, smart grid management, load forecasting, renewable integration, fault detection, energy efficiency. These all are the highlighted point in smart grid management. In entertainment, you can also see recommended system, content personalization. You can choose which content you want to see in your app or in your system. You can tell them the MLP, and it will filter out all of things, and you can see only those interested point which you already selected. So that will be the part of MLP. That is the application of MLP. User engagement prediction. MLP in cyber security, threat detection. That is most important. There are so many cyber crimes are going in our India also. So threat detection can be identified using MLP programming, network traffic analysis, malware detection, user behavior analysis. You can find out using MLP in cyber security. And the conclusion is the future of MLP in AI, continued innovation, interdisciplinary application, ethical development. So these are basically the conclusion. And this is all about from my side. Thank you so much for listening.
Thank you, sir, for the wonderful presentation. Sir, one query from one participant, sir. How
Yes, yes.
practically we implement neuron MLP? It is a combination of program and hardware both.
How practically is implemented neuron? Okay. So basically, it is very difficult to for those person who are not technical background. Okay, but it is not so much problematic. Basically, when you are doing the same thing, you first of all have a, if we are talking about for hardware, there are so many sensors are connected with the controller, and you are getting so many information. Okay, now collect all these information and start to make a data set. Okay, for an example, if suppose we are talking about air quality management. Okay, now in air quality management, what are the things which you have to be observed to find out the air quality? Okay, I'm trying to explain in practical format,
Yes.
because your combination is programming and hardware both. So if we are talking about the hardware, definitely you have to be identify those sensor who can identify the quality in the air of like carbon dioxide, nitrogen, okay, dust particles, pollution, carbon monoxide also is there. So there are so many sensors are available in the market. You can collect all these sensors, connect with your microcontroller and getting your real time result, right? Okay, when you getting real time result, you make a data set. Okay, now when you make the data set, or the data set, we think that the data set is very clear form, there is no error. Let's say we have a finite finished data set. Okay, now this data set is basically your input. Yani it means it is an input layer. Now the second layer is hidden layer. Now put this data to a Python programmed sample, Python programmed model on which you have to put these all data. Because I am working in that field in my PhD also. My PhD work is basically food contamination, and it is basically totally depend upon this type of models, that how can you predict that the food is pure or not, or what type of the chemicals is there, is there any pesticide all there, or there the quantity of the pesticide is what. I am predicting all of these parameter using AI models. So what you can do, put the data set into a model. What is model? It is a basically Python program, and we are not compromising with the Python program. You have to be written it, or you have to you can take from any site, from chat GPT or anywhere. Okay, that it is available anywhere. You are not don't try to write the code or nothing else. The system is already developed, you have to be use it. Okay, you can not develop it, you can use it. So put the data set on that particular model into the Python, and then a new system will be, a new input is coming, and then it will predict then it is good of or not, or it will start to predict that tomorrow, or your air quality index, or everything what you want to get from the output. So there is a hidden layer format, and the hidden layer format is basically a Python program, and this Python program is available. You can start with this, and you can see more videos, more information from the sources, and then you can start to work with them.
Thank you, sir. Any other
My
question?
pleasure.
Any other question from the participant regarding single layer perceptron, multi-layer perceptron? I think, sir, no question. So it has been a very informative and wonderful session, dealing in several key concepts, starting from the machine learning, deep learning, single layer perceptron, limitations, then advantages and need of multi-layer perceptron and everything. So thank you so much, sir, for such an informative session and wonderful explanation, hands-on training. Thank you so much.
Thank you, sir. Thank you so much.
So now may I request all the participants to turn on their cameras so that we may have one group photograph. Thank you, everyone. So once again, sir, on the behalf of Department of Applied Sciences, Poornima Institute of Engineering Technology, I thank for this wonderful session. Very nice. Means you have taken practical examples like human body, our skin, maybe treated as a sensor, like a bottle example. So very easy and understandable approach for the participants. Thank you so much. So some other day also we would have some other session. So thank you very much, sir. So now all of us may leave now. Participants are requested to fill the feedback form, which will be shared very soon, so that their attendance can be marked